So, that is what we looked into, and then this is the, as I said, SHGC factor for glasses, and then M factor adjustment for overhang and fins. So, this is a fraction. This is also prescriptive, they have given you how much you should do, but you can calculate and find it out actually. So, if you have a north facing, right, latitude greater than 15 degree, because it is all related to solar radiation. Now, since I have taken care of Indian scenario, India varies from 8 to about 32. So, up to 15 they have taken, and then 15 and above, that is that is what. So, latitude Thiruvananthapuram is on the 8 degree, around 8, and Leh, Ladakh, Srinagar, etc., will be somewhere 31 or something of that kind. So, this and radiation would, solar radiation, there is a thing in, if you go to equator or down below, then as I showed you earlier, the summer is in the month of December, February, December, etc., during that period of time, right. And you go to the northern latitude, the south surface receives quite a bit of radiation in winter, but not does not receive anything. Near equator variation is different. So, this covers for near equator situation, which I talked to you earlier in connection with the urban heat island issue. I said the radiation distribution summer and winter. So, therefore, if it is less than north, south also get a little bit of, south also might get little bit of radiation if it is close to equator, but in India of course it is at 8 degree, as I said, not 1. So, but in any case that is why the distinction is. So, north actually receives, basically sun's radiation received in north is very little, and you go to fit all northern latitude is still even lower. So, therefore, the multiplier is actually can be, you do not get any radiation. So, putting a overhang in north direction does not make any sense, because you are not blocking any sun. So, there is no multiplying factor at all. Here the blockage is very minimal. So, they have put in this, because this will be orientation north in upper latitude, it will receive a little bit of radiation only in summer morning, early morning and summer evening, because sun rises, day is long, greater than 15 degrees. So, day is long, and you come to this, even this will be somewhat, because then in winter also not close to, not it gets somewhat more than this. So, multiplying factor is more, but if you come to south, this is lower, south facing, because south facing receives a lot of radiation in winter, but you do not want winter radiation, you do not mind it coming. So, it is not very low either. So, only so based on those kind of considerations they will put in some, these are prescriptive factors, as I said prescription is given, but you can actually calculate them out and find it out, which is how much is the multiplying factor. East west they have put it same, and then projection value for projection factors. So, M factors for projection, so these are the, this is orientation is one thing, and this is the amount of, is the length actually related to the length, window length of this one divided by the height of the window. So, related to length of the overhang to the height of the window. So, that is how it gives you, and these values are therefore prescribed values are given. Vertical fins, again these are given. So, these projection factors are related to size of the overhang, size of the overhang. For example, this, if this is my window height, this is the overhang length. So, it is related to L by W, L by W. So, this is related to L by W, actually this is related to L by W. So, based on this, these values they have given, right. Considerations are something like this: higher latitude, day becomes longer in summer and shorter in winter, but lower latitudes the very it becomes longer, but not that much, comparatively less. And south surface gets lot of radiation in summer, I mean winter. In summer it does not get much less, while in the lower latitude you it is somewhat sort of moderated, this effect is moderated. So, that is why these values are projected, and as the overhang length increases, this factor becomes smaller, because more the overhang length, less will be the heat coming in. So, this is a multiplying factor, this multiplying factor will be multiplied with the value of the specified values given RDR, somewhere I have given those values, HSGC factors. So, you can multiply, you can actually multiply by m, that is what I was saying. So, you can multiply by m. So, SHGC of the unshaded fenestration product times multiplication factor. So, effective SHGC factor therefore, would be divided by multiplying factor, right. You can have so basically this the factor that you are actually allowable factor is this much, your factor can be higher, multiplied by the multiplying factor, which a fraction should be less than this, maximum this is given. So, it should be less than this for window to wall area ratio 40, right. So, that is how it is. So, for various projection factor, if the projection factor is more than 1, right, okay, this is for vertical fringe, these are for overhang, and both you have provided overhang and pane, then this is the ratios, both you have provided. So, these are prescriptive, you do not have to do calculation, just use this, but then this restricts the advantage of designing and optimizing the thing. Okay. Minimum visible transmission of glazing for vertical fenestration. Now, this took care of the heat coming in. One is the conduction gain through the opaque bodies, the roof, U values, etc., and direct radiation gain through the glasses, minimizing the infiltration, air leakages should not be there. And then if you have provided overhang, this has taken care of this, but then I must take care of lighting also. So, this is minimum visible transmission of glasses, that is prescribed. That means, how much should be the minimum value of the glass for visible light, because I can use special glasses, heat absorbing glasses, even I can go to photochromatic glasses. So, minimum value visual light, these transmissions are, these values are given, right. So, depending upon window to wall ratios. Okay. So, this is what is given, right. So, this is the other control, and if you have skylight on the roof, skylight shall comply with maximum U factor, maximum SHGC requirement, and skylight area is limited to minimum of 5% of the gross roof area for the prescriptive requirement. So, maximum 5%. So, industrial building they use, or elsewhere also one can use, and for different climatic condition, the skylight U values are given, and this is the maximum SHGC values are given, right. So, skylight roof ratio is the ratio of total skylight area of roof measured outside the frame to the gross exterior area, right. So, these are other guidelines given. Then actually this is, they say that this is based on life cycle model. How they have found it out? They found it out based on these values they have arrived from life cycle calculation, the code arrived at. So, 15 years life for service and 30 years life for envelope, that is what has been taken. So, for envelope 30 years of life with 3% interest rate. Well, that is the consensus of the people who actually formulated the code, and they calculated the energy cost at that point of time as 6 rupees per kilowatt hour. So, then the LCC life cycle cost, the initial cost of the insulation plus present value factor, by multiplying by present value factor, they have actually present value they have multiplied per watt, because 6 if you take. So, this will be 6 multiplying by the discount factor. So, every year 6, then multiplied by the kilowatt hour. So, consumption kilowatt hour, that is how they have found out. That means, this much kilowatt hour multiplied by 6, that is the expenditure every year, multiplied by the present value, that is what they have found out, plus initial cost, and then they did some regressions to find out this consumption kilowatt hour is a function of u value. They have taken it as a function of u value and done some regression. For fenestration they have done it in this manner, and linear regression they did to arrive at this u value which are given in the prescription. Prescriptive values, u values have been arrived from this. But there is one problem, problem is this, some 9 to 10 points regression to come out with a value of u. That means what they have done is kilowatt hour consumption, that is plotted as a function of u, some 9 values. So, if you are putting it in the code, from 8 to 9 values, that becomes too small, it has to be much larger, at least more than 30-40. So, this is one of the things, and another part of this is some buildings have actually adopted this, but their performance has never been measured so far. So, you got to check actually whether the energy consumption is coming this much or not, but this is the guideline that the code gives at the moment, trying to implement it, trying to see that there is a kind of consciousness or awareness, or if it is made mandatory then people have to use it. Obviously, this part is the building envelope part is one aspect, but more important aspect is the other ones, those are in terms of the commercial issues like the HVAC system. So, there if one looks at it, actually the one which consumes more energy are not actually acceptable at the moment. So, newer technologies are being favored by this kind of a code. Okay. So, this is what I was talking to you. So, we are looking at ECBC compliance methodology, envelope, prescriptive, this is what so far we have looked into, prescriptive criteria. There is a trade of options and there is a whole building performance method I just mentioned. Now, what is this prescriptive criteria, what we looked into now? So, for given climatic condition, given orientation of the wall, in window to wall area ratio, it gives you the prescriptive insulation values or U values and SHGC values, multiplying factor, etc., etc. So, this is how envelope is controlled in prescriptive method, but in this trade off methods you can trade off. For example, somewhere you may not be complying with the prescriptive criteria, but somewhere else you have compensated it. So, that guidelines actually allows for such kind of compensation, and how this compensation is to be done, that is also it suggests. And whole building performance method is, look at the whole building, and as I said, you take a building, standard building as suggested in the code itself, with the parameters matching with the building that you want to design, certain parameters, and then simulate the annual energy consumption in the standard building, reference building, and your building, your design building. If it is less than that, it is fine. If it is more than that, you have to change the design, either go to prescriptive or change the design as well. So, that is what it is. So, basic requirement of the building, design and operation, insulation requirement of the building envelope, that is what we looked into, and then prescriptive requirements, that is what it does. So, it looks into HVAC system, electrical system and water heating, that is separate, but envelope also it looks into it. Building envelope is what it looks into, and lighting system, that is what we just looked into ourselves. This part we are not keeping, and then system performance method of building system. Okay. So, this system performance methods are available elsewhere like OTTB, that is the Hong Kong uses, we will look at that later on, and whole building performance is the other kind of strategy, that is what I just mentioned. So, if you look at these factors, envelope, HVAC, lighting, electrical power, electrical power and solar heat water pumping, etc., etc. These are the factors, prescriptive, trade off and whole building performance. These are the three approaches. So, we looked into prescriptive so far. right. We have looked into prescriptive so far. Trade-off option is something like this. The building envelope complies with the code of the building envelope performance factor of the proposed design is less than the standard design, where the standard design exactly complies with the criteria of the code. The envelope trade-off equation is also given. So, what it is trying to do is gives a standard design, right, and if the envelope complies with the standard design has been has taken care of the prescriptive ideas, the prescriptive guidelines. So, if your overall design satisfies the prescriptive ideas, not satisfying individually, that is trade-off. That means you have done some trade-off somewhere. So, these equations are also given, but certain mandatory requirements are there for either trade-off or the whole building performance. One is natural ventilation. So, that should basically go with the National Building Code of India. How much is that is what I am saying, hygienic ventilation requirement minimum, or number of air changes. Minimum equipment efficiencies, that is prescribed according to certain code or a ASHRAE code, because they have adopted mostly from American situations. So, this much must the air conditioner must satisfy IS 1391, IS 1391 part, and packaged air conditioners is IS 8148 and etc., etc. So, they must meet the guidelines wherever is available. This is what is given with respect to, this is a kind of table which is available with respect to HVAC system. We will not look into this really, but such a table does exist. For example, this is based on this is based on kind of standard, test standard, ASHRAE standard. According to this values should be this values should it should satisfy these values. So, this is the equipment part of it. We will not look into the type of chillers that is there. Also the mechanism, these are mandatory requirements. So, mandatory requirements if you are using trade-off or you are using whole building performance, both cases these mandatory requirements are there. The other one is the control. System shall be controlled by a time clock. Okay. Can start and stop the system under different schedules for different day types per week. That means, you have to have some kind of control. Say without the control, this this is a mandatory requirement, you can't use. So, for example, if it is an office building, you must have a time schedule. So, you might have weekdays, weekend days, right. So, depending upon, for example, if it is a commercial building, office building, people will not come during the weekend. So, therefore, schedule would be different, maybe there is hardly any, maybe some specific works are there, therefore, it would be actually operated for a shorter period of time. And maybe Sunday nobody comes, and weekdays something like this, some places there is a half day, Saturday half day, some etc. So, this system, and if it is let us say a shopping mall or something of that kind, the crowd might be more on Saturday, might remain open for longer period of time. So, that kind of time schedule must be also given, and must be capable of retaining the program time setting during loss of power for a period of at least 10 hours. So, if there is a power failure, this program should still be maintained minimum for 10 hours. So, this is a mandatory requirement and includes accessible manual override that allows temporary operation up to 2 hours. So, in case there is a problem, there should be a manual override. So, I should be able to operate it for 2 hours, right. If the cooling system sizes are small, I do not need this. So, these controls are minimum, together the sizing of the air chillers, etc., sizing and their standards, and also related to the first one that I said was minimum equipment efficiencies, these are also prescribed according to some codes. So, all heating cooling equipment should be temperature controlled, that is what I said. where a unit provides both heating and cooling, control shall be capable of providing temperature dead band of 3 degree. You know, you have a operating differential. Supposing this you have fixed it at 25 degree centigrade, it will actually operate to 22 to 28. So, this should be shall be providing temperature dead band of 3 degree. So, this band here it is saying is 225 plus minus 1.5. This one is saying capable of providing temperature dead band, but this will depend upon your inertia of the system, the control system and inertia. For example, it might require longer time to cool. Supposing this I just this is the band, let us say. So, 2-point off-on control switch, supposing it has become too cold and the too cold, therefore, system is off. Now, it will go on heating, and as soon as the upper band upper value of the band says that this was 26, 25 minus 1.5 will be 23.5. So, this is 23.5, this is 26.3 degrees, 26.5. So, as soon as temperature reaches here, it will stop the cooling system. Then temperature will rise like this, and as soon as it reaches 26.5, start cooling. So, this will come now like this, and this will go like this 2-point off-on control switch, the simplest case operates in this manner. So, therefore, what is happening here? Heating and cooling energy zone should so separate heating, okay, etc., etc. Now, that means this rate at which actually it increases the temperature or rate at which cool, it depends upon the inertia of the system, rate at which is, so inertia of the system. So, therefore, this is the where separate heating and okay, both heating and cooling. So, it should temperature dead band of 3 degree, the supply heating and cooling energy of this zone is shut off and reduced. So, this band it is suggesting, and if I have inertia of the system low, it will take very long time to heat. That means, I have to operate for a less period of time. In this case, I actually will be operating for this period of time, then I will put it off and again operate. But supposing this happens slowly, or rather this happens faster, then I will have, it will depend upon the operating time will depend upon the inertia of the system itself, right. So, shall have either 2-speed motors, etc., etc. So, this is related to those mechanical system. Piping, insulation, these are also prescribed, right. So, design operating temperature 60 degrees centigrade, should have a R value 0.7 for insulation, and these guidelines are also given. With a design operating temperature less than 15 and refrigerant suction, etc. So, these values are prescribed for the system as well. Okay. Similarly, for the ducts, I think we will look into this in the next class, and we will look into the other ones, system. Finally, then the other part is whole building performance, and then look into other types of control, other types of energy control codes which are there. We will look into that.